So when we're doing synthetic division, what we want to do is look at our coefficients and write them like we did with synthetic substitution. 1, 5, -7, and 2 are my coefficients.
And would it be the same if you're missing something, you put 0?
Yep, if you're missing something, you insert a 0. Now, if we're dividing by x minus 2, the value that we want to use outside is 2. You with me? No, it was x minus 2, set it equal to 0, and solve, which means 2 is what goes out here. Okay, now we just do the same thing. So what's the first thing that we do? 1. And now I multiply the 1 by the, and put it under the, and add and get 7. And 2 times 7 is? And add and get, and 2 times 7 is? And add and get, right, okay? This last value is your remainder. Okay? We started with a degree of what in our original polynomial? Cubed. Okay? So we drop down, because we're dividing through by an x to the first, we drop down 1 degree. That means the 1 is the coefficient in front of the x squared term, and the 7 is the coefficient in front of the x term, and the 7 here is your linear term with no variable, and your remainder is positive 16 divided by what was the polynomial?
It's so much easier.
Yes, it is. That's why I show you this one second.
We just show you so you have 16 left, and then you went to 1x squared.
Because it started with a cubic, so our first term must be a squared.
And you just take those numbers there on the bottom?
These are all the coefficients of my terms. Isn't it easy? But I will give you a long division problem and a synthetic division problem on your homework. I can't remember. Okay, so we're going to line up this next one. I'm going to put 1, -1, 4, and what am I dividing by? Just -2, right? Good? Use your shorthand division, your synthetic, and that gives me a 1 here, and then a, 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 and then a. Okay. Raise your hand. Who can write this as a polynomial with a remainder? What would you write as your remainder? Pooja.
So it would be 1x squared minus 4.
You got it. Easy sneezy. Lemon squeezy. Yeah, you know what? We'll get to one. I think I have one in here. Okay. Who asked that question? Haley, or was that you? That was Pooja? Okay. Okay. Now, this just says divide, so you've got to be reading these instructions, girls. Okay? This one said to divide. That was what I wanted you to do for both of these. This one says factor completely. Factor completely. That means I don't want an answer as written as a polynomial. I want them as factors with parentheses. So we're going to use our synthetic division, and I'm giving you one factor is x minus 4. So we are going to divide it. If it's a factor, what should our remainder be? What should our remainder be? If x minus 4 is a factor, when we do our synthetic division, what should our remainder be? It'll be 0. If it's a factor, we don't have a remainder. Think about this. If I give you 48, is 9 a factor? No, because it doesn't go in there evenly, right? But is 7 a factor? Okay, because it goes in there evenly. So if something's a factor, it goes in there evenly, which means you get no remainders. You follow that thought process? So I'm telling you, we have 1, negative 6, positive 5, and 12. And we are dividing this. Okay, well, 6. Whatever. Whatever. Okay. My point was, if it's a factor, you don't have a remainder, right? Okay. No, I just didn't do it right. Okay, so what value am I going to put out here? I give you that this value is a factor. So in my head, if I do this right, my remainder right here should be 0. If I've done this right. Meg? No, because it's minus 4 in here. It's x minus 4 equals 0, so we use the opposite sign.
It works.
So 4, negative 2. Thank you. 0. I did it right. It's a factor. I don't have a 0. I have 0 as my remainder. Okay? Then this wasn't a factor. But if I'm telling you it's a factor, Pooja, you have to get 0. So let's write this as a polynomial. What is this polynomial? And I have no remainder, right? So I don't have to go 0 plus whatever. Or if it doesn't factor, then I... So to find the other factors, you can factor. You can use the quadratic formula. This probably does. But I'm just saying, if you can't find it, and I'm asking you to factor, then quadratic formula will also work. So this factors to x what? All right, so what were all my factors? My first one was x minus 4. I was given that. My other factors are x minus 3 and x plus 1. You following this? I was given this. This one was given. Yes. Making some sense? We good with this? All right, you do the next one. Because I said factor completely, given x minus 4 is a factor. So this is factored completely down here. Get another piece of paper because there's another page. There's a spiral notebook right there that no one's claimed that you can borrow some paper. You can just even have that if you wanted. I don't know whose it is. I didn't see a name in there. Yeah. Nah, this isn't working, is it? Oh, is it? Oh, really? What? Do I have a different problem than you do? What does this say? So that should be a 1? Oh, okay, thank you. Because I'm like, it's not working. Okay, now it works. We changed this right here. We said that this, you guys actually, if you had the notes, this was, I changed it on Moodle to 1. Yeah. Yes, ma'am. No. But what you could do is change it. If I gave you if I was dividing by x squared minus 4, that factors to x plus 2 and x minus 2. So then I could use 2 or negative 2. Does that make sense? Okay. So what does this factor to? Good. So my final answer then is x. Good. Are we good? We getting this? Easy? Okay. So now this says find the other zeros. Okay? I'm telling you that f at negative 2 is a 0. That means when x equals negative 2, that means x plus 2 was a factor. Does that make sense? If I'm telling you when I substitute in negative 2 I get 0, that tells me that x plus 2 was a factor. Well, synthetic substitution. We knew if it was a 0, if our remainder was 0, right? Okay, that's what we're saying. If I plugged in negative 2, I'm going to get 0, which is my remainder. Find other zeros. Find other zeros means factor, and set those factors equal to 0. So find the other zeros means factor and solve. So 1, 2, negative 9, negative 18. Is this the same problem that y'all have? Okay. What number am I going to use? I have to use negative 2. That's what I gave you. I told you negative 2 is going to work. 1, negative 2, 0, 0, negative 9, 18, 0. What is this polynomial that I'm left with? And what is funny about x squared minus 9? Which factors then to? So x equals negative 3 and x equals? So what was my first? 0. X was equal to? Negative 2. This was given. These are my other zeros. Correct? Look at the original polynomial. Body graph the tails. Where are your tails? Look back up here. This was cubic. Where are your tails? In which quadrants? 1 and? Okay, if these are my zeros, where is the graph crossing the x-axis? At negative 3. And where do my tails have to end? And down here and up here. So guess what I do? Go through and come down and go back up so that my tails end where they're supposed to. That's the general graph of that polynomial equation. Did you follow that? We did. We can find where it crosses the y-axis. And where does it cross the y-axis? At, no, negative 18. So this value down here is negative 18. That's your y-intercept. So when x is 0, our y-intercept is if when x is 0. If x is 0, this term drops out, this term drops out, this term drops out, and we're left with y equaling negative 18, right? Okay. So here's the next one. We're going to use negative 2, and we've got 1, 8, 5, and negative 14. Find the other zeros and sketch the graph for me. Mm-hmm. And know where your tails are supposed to be. That's why we learned where those tails were, so that we could graph these. And what is this value down here? Indicate it. Because if x is 0, Emily, this term drops out, this term drops out, this term drops out, and y has to be negative 14. So when x is 0, this has to be negative 14. Does that make sense? Are we good? Anybody got questions? We know that, and it's positive here and here. If it was negative, we would have started it this way and gone up and down. Okay?
Like on the top, like first we did like let's divide f of x equals whatever by like suppose just x squared.
Well, then I won't do that.
Throw it in like
Hold on a second. Let me give you the new